Her research focuses on the interface between biology and evolution. Particularly, she aims to understand how individuals interact with one another and their environment, and how responses to changes in the environment can shape these interactions. The work is mostly field-based and focuses primarily on reptiles. It incorporates aspects of population, community, behavioral, physiological, and evolutionary ecology. Her research has been featured in several high-profile journals such as Journal of Evolutionary Biology, Science, Austral Ecology, and more. Furthermore, she has appeared on several television outlets such as MSNBC, Discovery Channel, and more. Please welcome Tracy Langkilde.
Thank you very much. Okay, so I always thought it would be really cool to be an explorer, right? To go where no man has ever gone before, discover new worlds, hidden treasures, lost cities. But I also have this fascination with animals and can sit and just watch animals for hours and hours. And then I realized that I could combine these two. I could learn new things about animals, things that nobody had ever known before. And this is really what I do for a living. I guess I'm an animal explorer. I spend my time trying to figure out things that nobody knew about, and it's really nice being the first person in the world to know something. Makes you feel really smart. So I think this is the best job in the world. And I was inspired by documentaries that show often very vivid images of animals dealing with challenges. And these are often things like top carnivores taking down a prey, but there's also some really nice examples of much smaller animals that can take down animals much larger than them, for example, predatory ants. And there's always some really cool, gruesome images of things like parasitoid wasps that come down and lay their eggs inside live caterpillars. The eggs hatch out and the babies eat the caterpillar from the inside out while it's still alive. Really cool stuff. And fights. Animals are always, or we're always being shown, animals battling over resources, competing for territories or mates. And for obvious reasons, we usually see these kind of really dramatic outcomes of these interactions. Injury, death. It's because these are really striking and very memorable. But animals do have ways to deal with this. They have to, right? Otherwise they would not exist anymore. There's quite a remarkable array of adaptations for animals to be able to deal with challenges. Some of them, like this lizard, can use morphological camouflage so that the predators can't even see them. Some animals, like the mimic octopus, can actually change their shape so that they don't actually look like an octopus anymore and so that the predators don't recognize them. Some animals perform these very elaborate behaviours that communicate to the predator that they're amazingly fast, amazingly strong, and the predators are going to be totally wasting their time if they chase after them. Lizards do the same thing. They display these beautiful throats, and their display rate correlates with their endurance. So this is really good for both attracting the ladies and for showing the predator that you're not worth chasing after. And then there's other animals that take a much more straightforward approach. They do these big threat displays showing that they're big and they're scary to try and warn the predators off, or they rely on armour to protect them if the predator ever does attack. So understanding how these kinds of traits evolved is one of the things that really piqued my curiosity. How did the animals develop these traits in the first place? So without the use of a time machine, which I think would be really cool, but I don't know anyone who has one, it's very difficult to look at the evolution of these kinds of things without being able to go back in the past and look at how interactions between predators and prey changed and how these prey were affected by the predators before they had developed these strategies. It's very difficult to look at how these kind of coexistence strategies came about. But why do we even care? So I would argue that understanding the evolution of these kinds of traits is critical from two perspectives. Firstly, it tells us something about community membership. It gives us some insight into why some species are able to coexist, whereas others can't, and how animals are able to survive in the natural world in the face of these really strong threats. It also gives us insight into how these animals are likely to be able to deal with environmental change. So we know that these kinds of threats are increasing, and if we can know something about how animals can evolve the ability to deal with challenges, we might be able to better predict and manage threats such as invasive species. Now, I know that you all probably have an invasive species that you're passionate about, there's lots to choose from, and many of them have really important ecological impacts. But as well as being part of the problem, invasive species provide a really nice solution for being able to look at the evolution of these coping strategies. And for the purposes of my research, the nastier the invader, the better. So, my invasive species of choice is the red imported fire ant. These are a huge pest. They destroy garden beds, ruin manicured lawns and golf courses, attack pets, children, adults, and for this reason, people are very likely to report any signs of fire ant mounds to their local authorities. If nothing else, to make sure that these authorities, if nothing else, to try and get some advice about how to get rid of them. So this means that for these red imported fire ants, we have county level information of the rate and route of their spread. This is really important because it means that we can go to any one of these locations and we know how long the native species in this area have been exposed to these novel threats for. So we can look at how interactions between these novel threatening fire ants and the native species that they interact with change. We can look at how native species are affected by these fire ants or any invader if they're totally naive to them. We can look at what the impact is when the invasive species first moves into an area, and then we can look at how this changes over time, and we can see whether these native species develop any strategies that allow them to coexist with this invader. So the native species that I focus on is this eastern fence lizard. The important thing to know about this from my research is that fence lizards and fire ants use very similar habitat. They both rely on very open, sunny, disturbed environments because they need access to sunlight to be able to thermoregulate and incubate their eggs. So these species encounter each other quite a lot in the field. And fire ants are nasty. For any of you that are fortunate enough to have never encountered fire ants before, what happens is that if an animal, including you, blunders into a fire ant mound or comes across a foraging trail, these ants swarm in large numbers. So you will be covered by dozens to hundreds of ants before you even know it, and then they will sting synchronously. Each ant can sting up to 32 times before it runs out of venom, and if you're lucky enough to be a human, you end up covered in these horrible white pustules. But most animals aren't that lucky. What the fire ant venom does is it disrupts neuromuscular synapses, effectively paralysing the animal, and then they pull it apart and take it back to the mound before it dies. Not that great. So we know a lot about fire ants, but the general consensus is that fire ants only impact weak or sick vertebrates. So if you're a healthy, or at least not totally unhealthy vertebrate, what are you going to do if you get attacked by a fire ant? You're going to get rid of them and you're going to walk away, right? So we assume that it's only, for example, newborns or really old, sick animals that are going to be impacted by these things. But apparently lizards did not get the memo. So lizards that have never been exposed to these fire ants before, when they get attacked, they lie really still, hunker down, close their eyes, and hope these ants go away. This is not very effective. As few as 12 ants can kill an adult lizard within a minute if we don't swoop in and rescue them. And this suggests that any lizards that will get up and run away like this will have a survival advantage. And in fact, you do get lizards doing this. They do these rapid twitch stings which fling the ants off, and they move away so they don't continue to get attacked. It's really hard to see what these twitches are, so we got some high-speed video. You'll be able to see an ant crawling over the lizard's shoulder. It's going to attach onto the shoulder, and the lizard's going to think about it for a while. It's going to lift up his back leg and try and scratch it off. We'll do this a few times, and then soon you're going to see the ant flying across the room. There it goes. Just in case you missed it, this is in even slower motion. This behaviour can be really effective. And what it suggests is that if you have a population of responsive and non-responsive lizards, the ones that are responsive, that remove the ants, get up and walk away, are going to live. And assuming this responsiveness can be passed down across generations, they're going to live to have lots and lots of little responsive babies. Lizards that just sit there and close their eyes when they get attacked are not going to live, and they're not going to have non-responsive babies. So what we would expect is this gradual increase in the proportion of the lizards within a population that respond to fire ants. And that is exactly what we found. So you can see that with increasing time since fire ant invasion, so that is, as populations have coexisted with fire ants for longer and longer times, more and more generations, they've become more and more likely to respond to fire ants. So we get this nice increase in this adaptive survival behaviour the longer these populations have been exposed to fire ants. So I was really excited about this. I thought, this is great. This shows that these animals can respond. It supports this notion that the responsive animals live and pass these responsive genes onto the rest of the population. And I thought, you know, a really nice way to be able to show this would just be to test newborn hatchlings. If we get hatchlings from an uninvaded site, and a site that's been invaded for about 70 years, we would expect that if this natural selection was actually happening, that these newborn hatchlings would respond in the same way as their parents. That ones from long ago invaded sites would be very responsive, and ones from uninvaded sites would be less responsive. Conversely, it could be that we see this pattern because of lifetime exposure. Lizards from fire ant invaded sites have been exposed to fire ants, and they may have just learned to respond. In which case, we would expect that hatchlings from both sides would respond at very low rates. One of the things I really love about science is that you never know what to expect. And this threw me for a total loop. I found that when you raise juveniles, or when you test hatchlings from uninvaded and long ago invaded sites to fire ants, almost every single one of them responds to fire ants. We still don't really know what to make of this, but we can make some pretty good guesses. So what we do know is that lizards that respond to fire ants also respond to native non-venomous ants. And juveniles are born, they're really tiny. They're less than a gram, they're really soft-skinned, they're vulnerable to even native non-venomous ants. So what we think is that these juveniles are born with this innate anti-ant behaviour. Every time anything crawls on them, and in fact I had an undergrad who found out that you can tickle them with fishing line and get the same response. So pretty much they have this kind of responsive behaviour to anything that climbs on them, just in case it's dangerous. However, within natural uninvaded populations, adults reach this kind of size threshold where they're no longer vulnerable to ants, and so they lose this behaviour. As a lizard whose most common predator is a visually active hunting bird, it doesn't really make sense to do backflips every time an ant crawls near you. This is probably just going to attract predation attention. So within natural sites, juveniles have this innate anti-ant response, which is lost in adulthood. However, when fire ants move into an area, it changes the situation. All of a sudden, all lizards, no matter their age, are vulnerable to fire ant attack. And so it looks like we get this retention of this anti-ant behaviour across lifespans within fire ant invaded sites. Now remember, all of this is happening over 70 years. That's pretty quick. We used to think that evolution was this long process and it was in the kind of realm of the dinosaurs. And people were worried that native species would never be able to deal with the rapid changes that we're seeing in our environment because they would never be able to evolve fast enough. We're now starting to learn that this is not true, that we can actually see evolution happening on ecological timescales. This can be really important for thinking about management of invasive species or responses of species to environmental change. knowing that some of these populations can respond really quickly changes the ball field a little bit. So what this shows is that it's really important to think about the long-term consequences of invasion. If you think about it, if we went to a population that had not yet been invaded by fire ants, what we would conclude is that fire ants and fence lizards interact a lot, lizards get attacked, they lie there, do nothing, they get killed, we're going to see huge population collapses, doom and dismay, and if this were a vulnerable species, for example, we might rally to their aid. On the opposite hand, if we were to only go to the populations that had been invaded for a really long time, we would conclude the opposite. We would conclude that, yeah, fire ants and fence lizards encounter one another, but it's not a big deal. The lizards get up and walk away, shake them off, don't get envenomated, they survive, it's not a big deal. It also makes us think about how we implement our management. I think that we often think about preserving native species by putting them in this nice little protective bubble and keeping them away from any kind of threats in their environment. But the problem with this is that with a really stable environment, lizards are going to end up kind of adapting to that one particular scenario. And if anything changes, they're not really going to be able to adjust because you're not going to have this variety of traits that can be beneficial. So what we might want to start doing is making sure that we preserve large enough populations with enough variability that if something in the environment changes, hopefully at least some portion of the population is going to be able to survive this and can persist to pass these genes on to future generations. It also tells us that we really need to think about how we allocate our management efforts. So if we can predict what species are likely to be able to survive by themselves, then maybe we can help them do that without having to put all our resources into it. So for example, there's many invasive species that I'm pretty sure we're never going to be able to eradicate. But maybe if we can suppress their levels enough that we can give these native populations a buffer, that will give them enough time to adapt by themselves. And if we can figure out what species are able to do this and what species are able to adapt by themselves, and figure out some generalizations that tell us what species are going to be less likely to do this, we will be able to allocate these limited resources appropriately. And I think finally, this kind of research gives some more support to the idea that invasive species can provide a really nice way to understand processes that are structuring the communities around us, because they provide a really good lens into evolution in action. Thank you very much.